All right, hey everybody, thanks for coming today. So I'm here to talk to you guys about a product that I call Amp. Before that, I'll introduce myself first. So my name is Pierce. I'm originally from Minnesota. I went to the University of Wisconsin-Madison, studied computer science. I was previously at Amazon for about a year and a half. I worked on their Kindle and App Store teams. And I've been at Lyft for about 2 years since where I currently work. I work on the driver experience team. I work primarily on Android, but also a little bit on iOS as well. I also play a lot of Halo, so if you guys want to play with me, that's my gamer tag. All right, so for those of you who don't know what the Amp is, it's an embedded systems device with a front-facing and rear-facing LED display that was produced by Lyft. It kind of plays these cool and fun animations on the front and the back. It connects to our app via Bluetooth and is distributed to drivers after they meet a minimum ride requirement of, say, like 125 rides. It was a really interesting project, and I thought it was a really fun one to kind of go over to show what the embedded systems, developing for embedded systems is like, and hopefully this is potentially applicable to something you might work on. So the first thing you got to do when you're building any kind of device like this, or working with it, is understand what the product requirements are and what you're trying to build. Then you have to understand the hardware and the device protocol. And once you understand the hardware, then you can work on actually implementing this and integrating it into your app. And then finally, I'm going to take a step back and look at a high-level architecture breakdown of how this fits into Lyft's app architecture. So first is the product requirements. And the primary purpose of the Amp is to play these animations. And so you can see the green animation is what we call the beaconing one. And the beaconing animation occurs when a driver arrives at a pickup location, and a passenger can check their phone, and it'll see like a green light in their phone. And then they can say, oh, that's my Lyft over there, it's the green one. And that's what we call beaconing. The one in the middle is called a passenger greeting. The passenger greeting is displayed on the back of an Amp as soon as somebody gets in into a driver's car. So it'll say like, hi Pierce, or hi passenger name. And then the pink one is called the idle animation. And the idle animation occurs when a driver is outside of the context of a ride. We also can do a lot of fun animations like marketing campaigns. So for instance, if like the 49ers won the Super Bowl, we could play the 49ers colors on the front of it, which they probably won't this year. And this is what the in-app experience looks like. So we just have a couple screens here. The first is the Amp settings screen. Amp settings screen shows you whether or not the Amp is currently connected. It also shows you the current battery level of the Amp. And if you click any one of those other tabs in there, you can kind of walk you through different walkthroughs of how the Amp works. The second screen here is the pairing Amp screen. So as soon as you click pair Amp, that's how you kind of first connect the Amp to our Lyft Driver app. And that's kind of it for the product requirements. So now that we kind of know what we're building, we can kind of work with the hardware. And so Lyft didn't actually build the hardware ourselves. We actually outsourced it to another company. They came back to us and they handed me like a 26-page device protocol of like how the hardware actually worked. And so I kind of took that and broke it up into a few sections that are a little bit more digestible. The first section is the Bluetooth advertisement. So first you kind of need a little bit of background on Bluetooth. So Bluetooth operates on frequencies of about 2,000 to 2,400 megahertz. All Bluetooth devices like your phone or your speakers, your headphones, all operate on these frequencies and advertise what's called an advertisement frame. So they all advertise a specific ID, including the Amp, which advertises the Amp service. So to find the Amp, we look in this frame and find the ID from that series of bytes in the advertisement frame. The second section of this document was the commands, and the commands kind of looked like they were in the format of this, which is just a series of bytes. So we can send a series of bytes to the Amp, and we'll tell it what to do. The first byte is dedicated to the operation or opcode, and every subsequent byte are just arguments to that specific operation. We have a whole lot of our operations here. These are all of them. This is taken straight from that document. But I don't want you to get too overwhelmed, because they can actually be broken up into 3 different sections or 3 different categories. The first category are system-level commands. These are like setting the brightness, getting the battery level. Animation commands, which include starting animations and stopping animations. Authorization commands, which occur when you first connect to the device. You actually have to create a user and then log in that user in the future. And so the final section of this document was the command status. And the command status just tells you what's currently happening on the Amp. And this is what that looks like. And this is, again, straight from that document. It's a series of bytes that we constantly pull for to understand what's currently happening. The first byte is dedicated to the last or active command. This tells you what was most recently executed on the amp. The second byte is the command status, and the command status tells you, did that command succeed, fail, is it still ongoing? The third byte is called flags, and I did not name that, but it kind of includes a lot of different kind of stuff. Some more interesting ones from here are the active front and rear animation. So each animation actually has its own ID. So for beaconing and idle, they each might have ID 1 or 2. And so if you check these bits, you'll be able to determine what animation is currently playing in the amp. The next byte is just more flags, which is kind of more of the same. And then the final byte is dedicated to animation size. And so for each of our animations, we can actually upload them whenever we want. And they're uploaded in a series of bytes to the amp. And so this final byte of the command status register will tell you what the size of the last byte of animation that you tried to upload was. It's kind of a mouthful. So now that we kind of understand how the hardware works, we can work on implementing this and integrating into our app. The first thing we did was we created an Amp Droid module. It's just an Android. It's an Android module that we called Amp Droid, and it is the primary purpose of this SDK is just to interact with our Bluetooth device. And there's a certain series of steps you have to go through when kind of connecting to any kind of Bluetooth device. The first thing you got to do is scan for devices, and you'll start getting callbacks of different devices in the area. These might be speakers, headphones, and hopefully the amp. And if it is the amp, then we can just move on to connecting to it. And once we're connected, we can take those bytes of commands and just start writing to the amp. And each one of these commands can actually solicit a response. But first we need to enable that capability. So the fourth step is just enabling notifications for responses. And finally, once we've enabled that capability, then we can actually read the responses. So the first step is scanning, and I've outlined a method here. It's just the scan method, and we start taking the Bluetooth adapter from default Android APIs, and we start a low-energy Bluetooth scan, which will start getting callbacks of new devices in our area. And this is just part of default Android APIs. To find the device that we want, we have to take the bytes which were advertised in that advertisement frame, extract an ID from them, and then see if it matches the service that we're looking for, which is the AMP service. And if it is the one we're looking for, then we found our device. We can move on to connection. And connection is super easy. We just take that target device and call the connect GAT method. And GAT is the official name for the low energy Bluetooth protocol. And the next step is writing commands. So the commands are in the format that I mentioned before. It's just a series of bytes that starts with an opcode and arguments. And you take that command and write it to a characteristic, which can kind of be conceptualized as a register on the amp. So we're kind of just writing these commands to a register that the amp reads from. And so to get responses from the amp, we then need to enable those notifications for responses. And to do that, we take another characteristic, which is separate from our write characteristic. It's called the response characteristic. And we enable notifications for those responses. And so we'll start getting callbacks in this onCharacteristic changed method, which is part of the default Bluetooth GAT callback class. So every single time that the amp changes that characteristic, we'll start getting a callback in this method. We have to first check that the characteristic is equal to the one we're looking for, which is the response characteristic. And if it is, then we can read it and kind of parse the response. So now I can kind of walk you through a real-world example of trying to play an animation of the amp. So the first thing we do, like I mentioned before, is we pass an animation ID. This could be the beacon or idle animation. And then we call execute command, which will pass that an animation start class, which includes that animation ID. If I jump into the animation start class, we can see that this extends from a base class called emblem command. And every single one of our operations extends this base class, and they all kind of follow a very similar format. At the top, you have your really Java-friendly variables like animation ID, and at the bottom, we convert them to raw bytes, which are obviously a little bit harder to work with. But you can see that it's in the same format that I mentioned before, with that operation at the start and then the arguments on the right for those bytes. And now you can see the result, which is the device protocol. Every single operation that was mentioned in the device protocol has an associated class with it. So for animation start, animation stop, they all have a class that's in our Android Amp Droid module. So now we can kind of take a step back and look at how this actually fits into our application stack. So the very bottom of our stack is that Amp Droid module, which is just our SDK. And if I jump into that, we can see what the class hierarchy looks like. So at the very bottom, we have the AMP command executor, which is responsible for executing commands. We have the connection manager, which is responsible for exactly what it sounds like, managing the connection. Then we have the scanner, which was used to scan for those devices in the first place and eventually find the AMP. And then finally, the AMP client, which is our publicly exposed interface for consumption by anybody that's using our SDK. If I take a step up in our stack, we can see the infrastructure layer. And the infrastructure layer is really responsible for actually integrating an AMP into our app. So we could switch it between apps in theory if we wanted to release this SDK. So at the very bottom of the stack, you can see that we're using that AMP client from our SDK. We provided an additional layer of functionality on top of it called the AMP service. The AMP service does things like, for instance, when you first connect to the AMP, we'll actually save the MAC address of your AMP specifically to the AMP state storage class. And this will allow us to auto-connect to it in the future. And this is how we remember your device. And as we kind of go up, we can kind of see that these are getting a little bit more like user-facing. And so we have, right here, we have the battery service, which is just responsible for monitoring the battery life. Then we have the pack service, which is responsible for downloading a zip file from S3, which may include new firmware or new animations that we need to upload on the AMP. And then we have the firmware service and sync service that are responsible for unpacking that zip file and either installing new firmware or uploading new animations out of the AMP. And then finally, the most fun service, which is the animation service, which actually lets us play animations. And we also have a long-running job in the background called the driver ride update job, which at every state of our ride flow, so for instance, when we're going from like picked up to dropped off, we'll play an animation at each one of these state changes, and that uses the animation service. And now you can see we've kind of finished part one of our product requirements, which are just implementing these animations. If we take another step up, we can see that we're now in the UI layer, which only included those two screens that I mentioned before. The first screen was the AMP settings screen, which shows whether or not you're connected and also the current battery life, and so that uses the AMP battery service. And then we also have the AMP pairing screen, which again was responsible for first connecting to the AMP. And that uses the AMP service. And the AMP service was for initializing the connection to the AMP. And then after you're connected, we will walk you through how to use it. And that's when we use the AMP animation service, because we'll start playing animations on the AMP to tell you how it works. And now you can see we've kind of finished part two of our product requirements, which we're building this in-app experience. So I built the AMP, or worked in this project about a year ago, I'd say. And since then, it's now owned by another team at Lyft called Brand Experience, and they were kind enough to give me some numbers of what the impact of it has been so far. We have about 4 million rides per month that use AMP, which is pretty exciting. We also have about 125,000 drivers that own an AMP. We also have millions of brand impressions. So, a lot of people that are otherwise not seeing our brand are now seeing them kind of all over the city in the form of these lights in the front of these cars. And so, yeah, that's pretty much it for my presentation. I kind of wanted to plug like Android and Bluetooth. It's a pretty fun and somewhat tough thing to work with, but it's something that I kind of encourage everybody to try out at some point. If you have any questions, I'm here to answer them, and yeah, that's kind of it.